8.2, the law of cosines. So we've dealt with the law of sines, and we saw that that helped us to solve cases 1 and 2 for solving triangles. So now we're going to continue on to law of cosines, which will help us to solve cases 3 and 4, which are when you have two sides and the angle between them, or when you have three sides of the triangle. So as we start this, based on that fourth case where you have three sides, I just want to point out that for you to have a triangle, the two smaller sides must add up to a value larger than the longest side. Otherwise, you don't have a triangle. If we have side A equal to 9 centimeters, side B equal to 2 centimeters, and side C equal to 6 centimeters, 2 plus 6 is 8, which is not larger than 9, therefore you can't have a triangle. You have side A, side C, and side B, and this nice gap in between. So anytime you have a triangle, the two smaller sides must add up to a value larger than the longest side. So that's one thing that we want to keep in mind with this. Now that we have that determined, let's find the law of sines, or derive the law of sines. So I'm going to start out with the standard triangle again, A, B, C. A, B, C. But I'm going to modify things a little bit. In fact, I'm going to move B over to the side just a little bit here to make my life a little bit easier. But what I'm going to do is I'm going to say, let's assume that A is at the origin. So we put this on a Cartesian plane, an XY axis, and we put A at 0, 0, the origin. B is therefore located at a point X, Y. C is located at a point, well, it's B to the right of A, so it's located at a point B, 0. So this is some point xy. Well, if that's some point xy, then I can say that this is y, and that from here to here is x. That being the case, I can now say that the sine of A is equal to opposite over hypotenuse, y over c. So therefore, y is equal to c times the sine of A. And I can say that cosine of A is equal to adjacent over hypotenuse, or x over c. So x is equal to c times the cosine of A, which means that point B is now located at c cosine A, c, oops, get rid of that, c sine A. So I can give you B in terms of sides of the triangle, specifically side C, and angle A. So that's a good start. So now that we have that, we can use the distance formula to find the length of side A. So A squared is equal to the square root of, well, the distance formula says that the square of the length is equal to the, I should say that, sorry, A is equal to the square root, that the length of a side is equal to the square of the change in x plus the square of the change in y. Well, x in this case is c cosine A, and x for this point is b, and then y is c sine A, and for this point it's 0. So that's the difference in x from here to here, and the difference in y from here to here. If I square both sides, I get a squared is equal to c cosine A minus b squared plus c sine A squared. Now, what did I do here? I said c sine A minus 0. If you take 0 away from something, you end up with the same thing. So I just dropped that out as I made that transition. Now I'm going to square each of these. So a squared is equal to, and I've got c cosine A minus b squared. So that's a special product. That's the square of a difference. So I square the first term, c cosine A squared is c squared cosine squared A, 2 times the product of these, minus 2bc cosine A, plus the square of the second term, plus b squared, and then I square c sine A, and that gives me c squared plus c squared sine squared A. Now I see that I have a common factor, c squared is common between those two. So a squared is equal to c squared cosine squared A plus sine squared A minus 2bc cosine A plus b squared. And I notice that I have cosine squared A plus sine squared A, or sine squared plus cosine squared, which according to our Pythagorean identities is equal to 1. So therefore a squared is equal to c squared minus 2bc cosine A plus b squared. And then to clean it up a little bit, I'm just going to move the b squared over, and I get a squared is equal to b squared plus c squared minus 2bc cosine A. And this right here is what is commonly known as the law of cosines. Notice that we have A, B, and C, so we have the length of all 3 sides. B, C, length of those 2 of the sides, and the angle A. So what this allows us to do is we can relate, if we are given 3 of the sides, then we can find one of the angles. And if we are given 2 sides and the angle in between them, then we can find the other side. Now, as I showed with the law of sines, if I shift this around so that now B is here and I make C in relation to it, then I can come up with B squared is equal to an equivalent. And then if I shift it again, I can come out with c squared is equal to. So I'm going to go over here and I'm going to write the 3 equivalent statements. So a squared is equal to b squared plus c squared minus 2bc cosine A. B squared is equal to a squared plus c squared minus 2ac cosine B. And c squared is equal to a squared plus b squared minus 2ab cosine c. And those are the 3 ways that we can show the law of cosines. So we can erase all this. And since we have all that, we can now go into case 3, which is side, angle, side, where we have two sides and the angle between them, which is impossible to solve using the law of sines because we don't have anything opposite anything. If we have a side, an angle, and a side, I don't have the side opposite this angle, I don't have the angle opposite that side, and I don't have the angle opposite that side, so I can't use the law of sines. But with the law of cosines, I have two sides and the angle in between them, so I can then use that to find the other side. Once I've found the other side, now I have a side opposite an angle and sides, so I can use the law of sines to find another angle. And then when I get to having two angles, I can use sum of interior angles to find the third angle. Or if I was given three sides, then I could use the law of cosines to find an angle. Once I have an angle opposite a side, so I could then use the law of sines to find another angle, and then I can use the sum of interior angles to find the third angle. So let's take the case where we have two sides and the angle between them. Let me grab my paper to get my example. Angle A is equal to 42.3 degrees. Side B is equal to 12.9 meters. And side C is equal to 15.4 meters. So first let's draw what that's going to look like, because it's good to have that visual. So we have A, B, C, B, C, A. And what do we have? Angle A is 42.3 degrees. Side B is 12.9 meters. And side C is 15.4 meters. So that's what we're given. What do we want to find? We want to find side A, angles B, and angle C. So if we're going to do that, we obviously have to use the law of cosines. We have B and C, we have angle A, B and C, angle A, so we're going to use this first one. So we're going to say that A squared is equal to B squared, 12.9 squared, plus C squared, 15.4 squared, minus 2 times B, 12.9, times C, 15.4, times the sine of A, sine of 42.3 degrees. Well, let's start going through this and doing some calculations. So grab my calculator. 12.9 squared is 166.41. 15.4 squared, 237.16, minus 2 times 12 is 12.9 is 25.8 times 15.4 is 397.32 times the sine of 42.3 which is approximately 0.673. Continues on from there. Now something to take note of here is, be careful. Order of operations says multiply this before you add or subtract. I say this because a very common mistake at this point is that people go and they get this and they add these together, subtract that, and then multiply it by this, because they go, oh, I can just add and subtract. So remember order of operations, you're gonna multiply this first, and then you're gonna add subtract. So minus the 397.32 times this 0.63, whatever it happened to be, gives us 267.401, continuing on. 166.41 plus 237.16 gives you 403.57, so 403.57. And now if I subtract, I find that a squared is equal to 136.168, 668, 132, etc. Right, continuing on. And then a is equal to the square root of that, which is 11.669, 133, 1354, whatever it happens to be. And we notice that our lengths are to the nearest tenth of a meter. So I'm going to round that to a tenth of a meter, say A is equal to 11.7 meters. 11.7 meters. Now remember, when I take the square root of both sides, I don't have to take the negative square root, because a length has to be positive. So negative is not going to be a part of it. So now I have all three sides and angle A. So I can move on to using the law of sines. Take note that you never use the law of cosines more than once in any problem. Whenever you're trying to solve a triangle, if you have to use the law of cosines, you use it once to get you either the missing side or a missing angle. Once you have done that, you now have a side opposite an angle that's known. So you can switch over to the law of sines to find another angle. Once you've done that, you have two angles, therefore you can use the sum of interior angles to find the third angle. So that's our process. Law of cosines, followed by the law of sines, followed by sum of interior angles. The other thing to take note of is be careful which angle you decide to go for next. I have a side that's 11.7 meters, a side that's 12.9 meters, and a side that is 15.4 meters. Remember that in a triangle, the longest side is opposite the largest angle, and the smallest side is opposite the smallest angle. So when we decide which angle we want to find next, the wisest thing to do is use the smaller of the remaining sides. I've got 12.9, I'm trying to find angle B. I've got 15.4, I'm trying to find angle C. The reason I say use the smaller side is because the larger side is the only one that could possibly be obtuse. And remember the ambiguous case in the law of sines? If you take the largest side and try to find the angle opposite it, you don't know whether you're in that, you put yourself into that ambiguous case or not. Which means, is this an acute angle? Or is it an obtuse angle, but when I take the inverse sine, it gives me the reference angle? I don't know. But I do know that no triangle can have more than one obtuse angle. So if I take the smallest side or the second smallest side, anything but the largest side, I'm going to get an acute angle. So that's what I'm going to do. Instead of finding C, I'm going to find B because 12.9 is shorter than 15.4. Therefore, I know that B has to be an acute angle. So now I can do the law of sines. So I have 11.7. Let me actually write it as 11.7. So we're going to take A over the sine of A. So 11.7 over the sine of 42.3 degrees is equal to 12.9 over the sine of B. So the sine of B is equal to, and remember I multiply the diagonal and divide by what's opposite. So I have 12.9 times the sine of 42.3. Sine of 42.3 is approximately 0.673. So when I multiply that, I get 8.68 approximately. And then I divide by what's opposite, 11.7. Which tells me that the sine of B is equal to 0.74203, continuing on. So if I want to find B, I'm going to take the inverse sine of this, the inverse sine of 0.74203, which is 47.9054, Our angles are to the nearest tenth of a degree. So I'm going to make this the same, so B is equal to 47.9 degrees. Now that I have two angles, I can find the third one by using the sum of interior angles. So if I add 42.3 and 47.9, I get 90.2. So when I subtract that, so I say C is equal to 180 degrees minus 90.2. So C is equal to 89.8 degrees. 89.8 degrees. Now again, we like to list all the answers in the same spot, so I'm going to come over here and say A is equal to 11.7 meters, angle B is equal to 47.9 degrees, and angle C is equal to 89.8 degrees. And now I have solved my triangle by using first the law of cosines, because I didn't have any sides, I didn't have any known sides opposite any known angles. I used the law of cosines once, and then I switched over to the law of sines to get a second angle, and I chose the shorter of the two remaining sides to work with because I knew that would give me an acute angle, and then I just used the sum of interior angles to get my third angle, which in this case turned out to be really close to a 90-degree angle. So it wouldn't have been that hard for this to turn into an obtuse angle, and we wouldn't have known. If I'd started with that, I would have known whether this was 89.8 or 90.2 degrees. So just keep that in mind for when you're dealing with this. Law of cosines, once. Law of sines, make sure you're not dealing with the largest angle. Sum of interior angles, and you finish solving this triangle. So that is case 3, side angle side, using the law of cosines.